Yes, I got a phone call one evening from Richard Armstrong, who's an engineer. He works for an engineering consulting firm. And he was consulting on buildings like hotels and hospitals, large buildings in places like Beijing and New York City. In both of those cities, they have fire regulations that state that, well, in the first place, they have these emergency water containers on the roofs of the buildings, and they're cylinders. They're in the shape of cylinders. And Richard said to me, the local regulations say that I have to be able to guarantee a certain minimum water pressure for a certain amount of time, for 10 minutes after a fire starts, as an emergency water supply. And he said, no, I know it's obvious that at the top, if it's full, the water system, if it's full, then I can compute everything. But as the water level drops, the pressure is going to be less because the height of the water is less. And so I need to be able to tell my clients to build these cylindrical containers of sufficient to guarantee those minimal requirements. So could you solve that problem for me, he said. And I said, Richard, well, I could, but I think it would be much more instructive if you did it yourself. I'm going to give you a copy of my calculus book, and we have essentially that same problem here in this differential equations chapter. And I will suggest that you read this section, and that will explain how to do the calculation. Well, he did, and he was proud of himself, and I was proud of him too.